So you've done Lewis stat structures, and you figured out the shapes of molecules based on those Lewis stat structures. Now the question is, why do these atoms bond covalently to make these different shapes? So why do they bond and how do they do that? So what happens is when an atom does is, it'll take its orbitals, its s orbitals, p orbitals, d orbitals, and morph them into what we call bonding orbitals. That's called hybridization. So what a hybrid orbital is, it's a new orbital that's formed from combining original orbitals, usually the valence s and p orbitals. So, and here are the five, which we'll go over in a little bit. They're called sp3, sp2, sp, dsp3, d2sp3. So these are 5 different types of hybridizations. So what that means is an atom can hybridize into one of these 5 types of hybridization forms. Okay, we'll get to those. Essentially what happens is, if you look at an atom, there's its nucleus. You got your 1s level, and you got your 2s, then your 2p. All right, there's your one of the 2p orbitals. There's your other 2p orbital. And then there's your third p orbital. And see, these are really not conducive to bonding or hooking up with other atoms. So what happens is all those orbitals, right, those s and p orbitals will actually morph to make something that looks like this. So there's your nucleus, and then you'll have one lobe like that, a second lobe, a third lobe, and a fourth lobe. Okay? So you have your 2s and your 2p orbitals here. Here you have what we call sp3. Okay? Your 2s, 2p, that's 4 orbitals total. Here these are called sp3 orbitals, 1, 2, 3, 4 orbitals total. So all we're doing is we're taking 4 orbitals and morphing them into 4 different looking orbitals. All right, so we're going to look at each of these and examples for each of these. We'll do the sp3 first because that's the easiest. Okay, so here's how sp3 works. Okay, so imagine this. If we look at carbon. Okay, carbon's 1s2, 2s2, 2p2. There's your 6 valence electrons. All right, and kind of imagine the orbitals kind of like on this little energy level here. This is your s, okay, so that's your 2s, and these are your different 2p orbitals. All right, so, and we're just going to look at the valence electrons here. So 2s1, 2s2, 2p1, 2p2. All right, so we got that. All right, so that's as an atom. Sorry about that. All right. Now, what's ready to do bonding, what's going to happen is these 4 orbitals, 1, 2, 3, 4, okay, those 4 orbitals are going to kind of morph and mesh and become 4 equal energy bonding orbitals. And we call those sp3. That's because you're taking the s and the 3p orbitals and make them all similar in energy orbitals. So these 4 orbitals will morph, make these bonding orbitals. And now these electrons will rearrange and fill in 1, 2, 3, and 4. So they'll fill in those 4 different orbitals there. Right? And this is where you get carbon with its 4 bonding sites. Each one of these areas here are your bonding sites. And that's how carbon will bond to 4 other different atoms. So if you see carbon, like in a tetrahedral molecule, if you see carbon with 4 bonding sites, that means it's sp3 hybridized. So that's one example of sp3. Here's another example of sp3. This is with oxygen. Oxygen has 8 electrons, so that's 1s2, 2s2, 2p4. All right. So the 2s2 and the 2p4, that's its 6 valence electrons. So here's your 2s and 2p orbitals here. 1, 2, 3, 4, 5, and back to your 6. All right, so again, those 4 orbitals are going to mesh together to make 4 sp3 orbitals. Those 6 valence electrons are going to go in here. 3, 4, 5, and 6. All right, so now if you remember with oxygen, when we drew out the Lewis-Stott structure for oxygen, it looked like that. Okay. That's where the sp3 comes in. That's what we got here. Here's your 2 shared pairs of electrons. So that's there. And then that's there. And then these are your bonding sites. That's where they're ready to take on another atom. Okay. So these hybrid orbitals are good for 2 things. Actually, they're good for 3, but we're up to 2 right now. Okay, the 2 things hybrid orbitals can do. A, they can be bonding sites. B, they can be orbitals for unshared pairs of electrons. Okay, so that's how sp3 works. And a third one, just for good measure, we'll do fluorine here. 1s2, 2s2, 2p, 5. 9 electrons total, 7 valence electrons. So 1, 2, 3, 4, 5, 6, 7. All right, so if we blend those together, make your 4 sp3 orbitals. 1, 2, 3, 4, 5, 6, 7. All right, so what do we got here? We got fluorine. That was the Lewis-Stott structure for fluorine. All right, well, there's 1, there's 2, there's 3, and here's your bonding site. So there you go. All right, so anytime you see a combination of single bonds and unshared pairs of electrons, they total 4 different areas. That's sp3. Okay, again, so sp3 represents 1 s orbital and 3 p orbitals combined to make 4 individual hybrid orbitals. So that's sp3. So now the next one we're going to do is sp2. So here's how sp2 works. We're going to do carbon again. 1s2, 2s2, 2p2. So 1, 2, 3, 4. Okay. So now what happens is we got our 4 orbitals, 1 of our s's and 3 of our p's. So at sp2, what's going to happen in sp2 is only 3 of the orbitals are going to hybridize and leave 1 all by itself. So these 3 orbitals, this s and these 2 p's, are going to form 3 hybrid orbitals called sp2 hybrid. So these are your hybrids. Okay, this is just your regular p orbital. Hasn't changed. Same energy level, everything. No different. All right. So these 4 electrons, 1, 2, 3, and then the 4th one's going to go up there. All right, so that's your 4. All right. So now what happens here is, what we got here is, with these 4, if we look at carbon again, all right, these are your hybrid orbitals, 1, 2, and 3. So this one right here Okay, that's a lot higher energy. What that's going to do is be for a double bond. Right, so what's going on here is you'll have, if you have your carbon, we'll bond it to another carbon here. 1, 2, 3, 4. Okay, so you're going to have that, and these two, so that's one of your sp2s. These are also going to bond. So this right here, these are going to hook up to be your p orbital. So that's going right there. And then this is going to be, one of these is going to be your single bond, your second of your double bonds. And that's going there, and that's going to be there. All right. So yeah, so that's how sp2 works. sp2 is you create 3 hybrid orbitals, and then an extra p orbital that that becomes a double bond, or a second of a multiple bond. Okay, so, okay, another example here for sp2. We'll do boron here. 1s2, 2s2, 2p1. All right. 2s2, 2p1. All right. So again, these 3 are going to morph together to make this 1, 2, and 3. So that leaves a p orbital all by itself. Well, remember, boron has 3 bonding sites, right? So this right here, nothing's up there. That is your empty orbital. That's that p orbital that's unused. And then these bonding sites, just like before, these are your different hybrid orbitals. So that's how sp2 works for that. All right. So that's how sp2. So sp2 with hybrid with sp2, it means you have 3 hybrid orbitals, and that p orbital are good for 2 things. 1, it's empty, or 2, it's the second of a double bond. All right, there you go. So that's what p orbitals work in sp2. All right, so again, sp2, it's just 3 hybrid orbitals, 1 s and 2 of the p's. So there's your sp2. All right, now sp, just regular sp. So this one. All right, here, let's start with beryllium iodide for that, BeI2. I'm sorry, just beryllium. Okay, so we're just going to start with beryllium. Okay, beryllium is 1s2, 2s2, right? So there's your 2 valence electrons. And remember, it's a second energy level. Beryllium has second energy level electrons, so the 2p is available. They're just empty, but they're there. So what's going to happen is it's going to take this s orbital and one of the p orbitals and morph them, blend them together to make 2 hybrid sp orbitals. And the 2 electrons are going to go there. Okay. Again, remember with beryllium, it just has its 2 bonding sites. 1 and 2, there you go. Then the p's orbitals, those are just empty. So that's how sp works. Now another example of sp, we'll do carbon again. So 1s2, 2s2, 2p2. Okay. S, P, P, and P. Okay, 1s2, 2p1, 2p2. All right, 2 of those electrons go over here, 1 and 2. Then the other 2 are going to be there. Okay. So now you have 2 bonding if you have 4 bonding sites here, but 2 of those are hybrids. So remember the carbon, you got those. That leaves these 2 other electrons. So like last time with the sp2, it was a second of a double bond. So it could do that. So it makes double bond there, makes a double bond here. So these 2 right here be make it 2 double bonds. Right? Now what else can it do? Right? So we'll show that on the next slide here. So here's your 2 double bonds. So essentially you get this one and this one making 1 double bond. Right? Which is that and that. And then these 2 right here going to pair up to make your other double bond. All right, so that's your SP. That's your SP. There's one of the SP hybrids. There's your second SP hybrid, and then there's your 2 p orbitals. There's your 2 double bonds. Now, what SP can also do, if we'll do carbon again, so here's your 1 and 2 and 3 and 4. So 1, 2, 3, 4. So it can do 2 double bonds, or what else can it do? It can also make a triple bond. So yeah, so what happened is I'll take these 2 p orbitals, we'll hook up with one of the sp orbitals. So there's your 1, 2, 3. There's your 3 bonds right there. And then this lonely old, all left alone hybrid orbital right there. That becomes your single bond there. So there you go. So that's SP. So there's your SP3s, SP2s, and SPs. So I know it's kind of confusing. That's how it works. So just a quick summary. I have this in the table here. So this will help you out, and then we'll do some examples. And then we'll do the DSPs and the D2SP3s and the DSP3s I'll do in a second. So here's a summary. Hybrid orbitals, they can be one of 3 things. It can be one of a multiple bond. So if you have a double or triple bond, one of those 2 or one of those 3 is a hybrid orbital. They can be any single bond. So anytime you see a single bond, that is a hybrid orbital. They can also contain a lone pair of electrons. So if you see any of those 3, that would be a hybrid orbital. P orbitals, you got one of 2 options. So a p orbital is the second and or third of a multiple bond, or they can be empty. So like we showed you before, they just no electrons are in there. You know that's a p orbital with nothing in it. If you see a double bond, one of the bonds is a hybrid, the other bond is a p orbital. If you see a triple bond, one of those 3 bonds is a hybrid, and the other 2 are p orbitals. Right. So we'll go through some examples here and it'll make a little more sense, because I know the graphs can be kind of confusing. All right, so NF3. Okay, if you sketch NF3, NF, and F, I'm going to put all the dots in here. Okay, we're going to find the hybridization of nitrogen and the hybridization of fluorine. Okay, so look at fluorine first. So fluorine has one shared pair of electrons, and 1, 2, 3 unshared pairs. So we got 1, 2, 3, 4. So there are 4 areas where there's hybrid orbitals. All right, so out of ones we did before, sp3, sp2, or sp, which one would that match? Which hybridization would it match? that would be sp3, right? Because sp3 is one s and three p orbitals, a total of 4 orbitals. 1, 2, 3, 4. All right. All right. If we look at nitrogen, okay, same thing. We got 1, 2, 3 shared, 3 bonds. That's 3 hybrid orbitals right there. Plus unshared pair of electrons. That is a 4th. So that also is sp3. Voila. Nice and easy. All right. If we look at CO2, so carbon and oxygen. So that's the Lewis stat structure for carbon dioxide. So we're going to look at carbon and oxygen. We'll do oxygen first. So if you look at oxygen, 1, 2 unshared pairs of electrons. So that's 2 hybrid orbitals there. And then we're going to take one of these 2 bonds, because one's a hybrid and one's not. So 1, 2, 3. So that's 3 hybrid orbitals. So what we've done so far, what represents 3 hybrid orbitals? sp2. 1 s and 2 p orbitals. Total of 3 hybrid orbitals, and that's what we got for oxygen. Alright, so we look at carbon. Over here, we're only counting 1, because one's a hybrid and one's a pi bond, so we got 1 over here. And over here we got 1, and we're not counting the other one. So we got a total of 2 hybrid orbitals. So if you have 2 hybrid orbitals, that would be what? That would be sp. There you go. Alright, last one, HCN. So if we do HCN, nitrogen, carbon, and hydrogen. Okay. So nitrogen, 1 unshared pair, and we'll count 1 of these bonds. So that's a total of 2 hybrid orbitals. So that's sp. Okay, what about carbon? Okay, you got the 1 bond here, and we count 1 of those. So that's a total of 2. So that's sp. All right. Now what's hydrogen? Trick question. Hydrogen is not hybridized. So we would just say it's 1s. Okay. Now why is it not hybrid? Only the 1s orbital is available. There's no p orbitals in the first energy level, right? Just 2. So a second energy level can do 2s and 2p, but which means it could do sp2s, sp3s, sps, but the first energy level can't. So hydrogen will never hybridize. Just can't do it. Too small, too tiny. So that's your hybridizations for sp2, sp3, and sp. Okay. Now we'll talk about sp3d and sp3d2. Right? So if you look at phosphorus, our phosphorus has, it's 5 valence electrons. So 1, 2, 3, 4, 5. Okay. Now remember, when you have PCl3, right, or phosphorus can do its 5 bonds, something like this, where these will split up. All right. Well, here's what happens. You got 1, 2, 3. And then before you had the pair, well, now you got 4 and you got 5. So what happens is these 2 extra orbitals from D, or I'm sorry, the 1 extra orbital from D will pop down and make an extra orbital there. So now you got 5 hybrids. Right? And you just go around, look at this. Here's 1, 2, 3, 4, 5. So it's S, P1, P2, P3, D. SP3D. Right? And lastly, sp3d2, so that's like sulfur. 1, 2, 3, 4, 5, 6. All right. So now these two orbitals, these two d orbitals, will also become hybridized. They'll pop down and make those two. So now 1, 2, 3, 4, 5, and 6. That's your sp3d2. That's why sulfur, like as in sulfur hexafluoride, can form 6 bonds. All right. 1, 2, 3, 4, 5, 6. S, P1, P2, P3, D1, D2. sp3d2. Okay. So those are different hybridizations. The easiest way to do it, again, is just kind of follow the table. See how many single bonds you have. See how many unshared pairs of electrons you have. Add those up, and just match that with the hybrid orbitals that we just went over. So that's hybridization. Okay. Once you get the hang of it, it's actually pretty easy and pretty quick. And very last thing we have here, this is super quick. Sigma and pi bonds. Really, all hybrid bonds are sigma bonds. So that's a sigma bond, that's a sigma bond. All right. These are called 1s because they're not hybridized. A double bond is a pi bond. All right. So in a multiple bond you have, so in a double bond you have a sigma bond and a pi bond. In a triple bond you have 1 sigma and 2 pi's. So if you have something like this, all right, you got 2 pi's, 2 pi bonds, and 1 sigma. And there you go. That's hybridization. Okay, just take your time when you're doing this. It's not hard once you get the hang of it. It actually goes pretty quick. So just go over that, and it'll be easy once you get the hang of it.